Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 15 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3234. Count the number of substrings with dominant ones. So in this problem, you are given a binary string S. That simply means our string consists of 0 or 1, right? We have to return the number of substrings with dominant ones, right? A string has dominant ones if the number of ones in the string, right? If the number of ones in the string is greater than or equal to the square of number of zeros in the string, right? Square of number of zeros in the string, right? So our string is going to be dominant if zeros square, right, is less than equal to the number of ones, right? This is what we need to do. That's it, right? Okay, so here if you see this example number 1, right? So this is my string, right? 0 0 0 and then 1 1, right? And here for this output is 5, right? So first, let's say if you pick just this substring, right, just this one, right? So in this substring, how many number of zeros are there? 0. How many numbers of ones are there? Right, 1, right? And here if you see zeros, right, 0 0 square is less than equal to 1, 0 is less than equal to 1, true, right? So this is valid, this is dominant, right? Same way if you pick just this one, so this one is also valid, right? And if you pick this substring, right, 1 1, so this is also valid, right? Here also if you see the number of zeros is 0 and number of ones is 1 2, right? So 2, so here see 0 is less than equal to true, so this is also valid, right? Same way if you pick this 0 and this one, right, 0 and 1, okay? So here number of zeros is 1, number of ones is 1, so 0 square, that is nothing but 1 square, right, is less than equal to 1 1, this value. So yes, this is also valid, right? So this is also valid. Same way 0 1 1 is also valid because number of zeros is 1, and if you do 0 square, this value is less than equal to number of ones, so 1 is less than equal to, right? So this is also valid. Clear? So output is 5. So if you see here, substring starting from 3 to 3, right? So this is what you have, right? 0 0 1 1. So if I just give the indexing here, so 0 index 1 index 2 index 3 index 4 index, so 3 3 means this, just this part, then 4 4 means just this part, 2 3 means this 0 1, right? 3 4 means this 1 1, right? 2 4 means this complete, right? So here number of zeros, right, number of ones here we are writing, right? And here just apply the formula, 0 square is less than equal to ones, right, everywhere, right? So 0 square is 0 0, 1 square is 1, 0 square is 0, 1 square is 1, right? So 0 is less than equal to 1, true. 0 is less than equal to 1, yes. 1 is less than equal to 1, yes. 0 is less than equal to 2, yes. 1 is less than equal to 2, yes. That's it, right? And here these are the constants. S dot length from 1 to 4 into 10 to the power 4, and S consists only of characters 0 and 1. Clear? So now let's see how beginner is going to solve this problem, right? So let's suppose this is your string 0 0 0 and 1 and 1, right? And here if I just give the indexing, 0 index, 1 index, 2 index, 3 index, 4 index. So in brute force, right, how we are going to solve it? So first I'm going to place my I here, and then I'm going to place my j here. We have to run two loops, right? So first I will check this string, substring, which is starting from this I. So I is nothing but it is showing the starting point, and j is nothing but it is showing the ending point, right? Ending point, and I is showing the starting point, right? So here I will just check this, right? I will find out all the substrings, then my j is going to move forward here, right? Then 0 1, right? So here I is fixed, then this, so this is 0 0, then 0 0 0, right? then my j is moving here, then this substring 0 0 0 and 1 here, right? And then my j is going to move here, so 0 0 0 1 1, right? This is how I'm going to do, right? And then after that, once this is done, then after that my I is going to move here and my j is going to start from here. Then this I'm going to pick, then my j is going to move here 0 0, then my j is going to move here, I will get 0 0 1, then my j is going to move here, I will get 0 0 1 1, right? Like this. Then next time my I is going to move here and j is going to start from here, so I will get 0, then j move here 0 1, then 0 1 1, right? Done. So this is what we have to do, right? Using brute force. Then I from here, then I will get 1, then 1 1, then in the end I is going to start from here 1. Okay, so this is just very brute force, right? Clear? And now, so here if you see, you are running two loops, right? So you are running one loop I, which is running from 0 to n. Then also you are running one j loop, which is also running from 0 not 0, it is starting from I to n, right? This is what's happening, right? So once you do all this, right, after that you have all these substrings, right? So for all these substrings you also have to do one more thing here, right? That is nothing but the calculation of the number of zeros, right, and number of ones, right? So here this particular example, in this particular example, n value is just 5, small, right? But it can be very big, right? This value, it can be up to 10 to the power 4, right? 4 into 10 to the power 4, right? I think this is the size given, right? 4 into 10 to the power 4, right? This can be very big. So to calculate the number of zeros and number of ones, right, you have to iterate over all this again, right? You have to iterate over all these values, you have to iterate over all these values, you have to iterate over all these values. And if size is 10 to the power 4, right, let's suppose 10 to the power 4 is the size, then again you have to iterate over all this, right? So here also you are iterating over you can say j is nothing but the end minus I plus 1. So this is going to be the size of this, right? Clear? So 0 0 1 1, right? If you just pick this, so 0 index, 1 index, 2 index, 3 index, right? So here I, this is starting and this is the ending, right? So j minus I plus 1, if you do, you are going to get 3 minus 0 plus 1, that is nothing but 4. So 4 is the size of this, correct? So this size can also be very large now, it can be 4 into 10 to the power 4, right? So inside this, to calculate the number of zeros and number of ones, you are again running approximate of n times, right? Right. And if it is valid, if it is valid dominant substring, then you can simply do count plus plus, right? So this is nothing but very brute force, right? So here if you see, this is running of n time, this is running of n time nested loop, and inside this also you are counting the number of zeros and ones for this particular substring, which is starting from I ending at j, for of n time. So the time complexity is going to be of of n cube, right? This is going to be time complexity, right? Right. So here your n value, it can be 4 into 10 to the power 4, right? So it is going to be if you just pick this, not 10 to the power 4, right? Let's ignore this 4. So 10 to the power 4 cube, so you are going to get 10 to the power 12. Definitely you will get time limit exceed error with this time complexity, right? Okay, so we can little bit improve our brute force now, right? So this is worst approach, I can say worst approach, right? Now I can improve it little bit I can improve. How I'm going to improve it? So here, to calculate the number of zeros and number of ones in of n time complexity, I can solve this in of one time complexity, right? How I'm planning to do that? Okay, let's see. So same example 0 0 0 and 1 1 here. Okay, so let's suppose your I is here, your j is here. So in this you want to find the number of ones and number of zeros, right? You want to find number of zeros and you want to find the number of ones, right? These two things. So I'm not saying that now I'm going to iterate over all these again from here to here to calculate number of zeros. What I'm planning to do in this, right? So here this is 0 index, 1 index, 2 index, 3 index, 4 index, right? So I will calculate the number of ones, right? Cumulative sum, or I can say prefix sum, right? So until here 0 number of ones, until here 0 number of ones, until here 0 number of ones, until here 1 number of 1, right? Until here we have 2 number of ones. So here if you see, this 2 is nothing but the number of ones which we have encountered starting from here, starting from here, starting from here until here. How many number of ones, right? How many number of ones we have starting from here. Okay, now same way, this is nothing but the number of ones starting from here, starting from here. How many number of ones we have, right? Okay, now I want to calculate the number of ones in this window, right? In this window I want to calculate the number of ones. So it is very simple now. So how I'm going to do? So this is the number of ones starting from here until here. From this, if I subtract the number of ones until here, right, until here, then I will get the number of ones in this window, right? So what I'm saying here, let's say you are starting from here and until here, this is nothing but a point. Until here you have 20 ones, 20 ones, right? I want to calculate the number of ones in this window. Let's say this is nothing but D point, right? Let's say this is B point and let's say this is C point. Okay, I want to calculate the number of windows or number of ones until here in this window, right? Till B, I know that my number of ones is 10. Okay, number of ones is 10, and until C I know my number of ones is 12, right? Okay, so now how you are going to calculate, how you are going to calculate this? Okay, so this is what you need to calculate, right? This is the part you need to calculate. Okay, so A to D you have 20 number of ones, right? A to C you have, starting from here until here, you have 12 number of points. Okay, so B, just I'm adding it, you can ignore it, right, if you want. Okay, just I'm showing what you need to do. Okay, so here see, now you need to calculate CD, right? So CD is nothing but A to D minus A to C. So that is nothing but 12, 20 minus this 12, right? 12 is the number of ones until C, right? So you are going to get 8. So 8 is the result. So this is the approach that I'm trying to take here now. So in this I need, right? So until here how many number of ones, and until here how many number of ones, right? So it is starting from somewhere. So left out area is this one only, right? So I will get that result. Okay, so in one go, first I will calculate the number of ones, right? And whenever I want to calculate the number of ones in this range I to j, so I will be able to solve it in of one time complexity. So this is nothing but I'm applying prefix sum logic, right? Prefix sum type logic. Okay, so now your time complexity is, you are running one I loop which is running from 0 to n, then inside this you are running one j loop which is starting from I to n, and inside this, since you have already calculated prefix sum from I is equal to, for I is equal to 0 to n, you already calculated the prefix value here initially itself, right? And in this it is going to be of 1 only, right? So overall time complexity for this part is going to be of n square now, right? So from of n cube we now come to of n square, right? So you can try to code with using this approach whatever I have explained. Okay, so time complexity is going to be 4 into 10 to the power 4 square. So it is going to be, okay, if you just take this, okay, ignore this part. So then it is going to be 10 to the power 8, which will also give you time limit exceed error. Okay, so you can try this. You will see that your approach will fail for few test cases. Okay, for most of the test cases maybe, right? So this is also the issue, right? So now again we need to improve it. So what we did, we improved it from of n cube to of n square. Now we need to improve it further, right? So this is worst approach, right? And this is little bit optimized brute force. Okay, worst brute, it is also brute force only. Okay, this is little bit, and now we have to more optimized one we have to do. Okay, so let's see how we are going to do that. See, only two things are changing, right? One is I from 0 to n, right? And for here we are running one loop, j is equal to I to n, right? So now in this case, right, definitely we have to go over all the substrings one by one, right? But we need a little bit optimization here. So I is nothing but the starting point, right? And j is nothing but the ending point, right? So now instead of checking j for all the values from I to n, right, can I skip few indexes? Can I skip few indexes for j which are unnecessary, right? So this is what I'm trying to see, right? So I'm going to fix it. So j, if it is running like this previously for all the indexes, now I'm trying to see if I can make a jump to j like this, right? Like this. Maybe there is no need to check these things, right? I will see that. Okay, so let's see how we can check that. Okay, so this is what we need to see, right? Number of zeros, number of zeros, not zero square. This value should be less than equal to number of ones, right? Okay, so from here let's see few cases. Let's see few cases. Okay, so let's see case 1. Okay, case 1 is nothing but, you can say, if your 0 square, okay, if 0 square is greater than ones. All right, so let's create some example. Let's create some example. Okay, so let's say 1 1 0 0 1 1 1 1 0 1 0, something like this you have. Okay, let's say this is the example, and let's say your I value is here and j value is here. Okay, so now in this case, this is the window, right? This is the window, right? So here number of zeros in this window is 2, number of ones in this window is 0, and if you see 2 square is greater than number of ones, which is nothing but 0. So 4 is greater than 0, right? So this is my case 1, right? So now in this case, right, now in this case, right, this 0 and 0 is fixed. Now later on I am moving my j forward only, right? Every time my j is moving forward only, right? So next time 1 may come, right? Or there may be 0, right? Anything will come, right? After this, right, my j is, my I is fixed starting. Next time my j is going to move here, right? J is moving like this now, like this. This is what I want to ignore. I don't want to check few things, right? I don't want to check all the indexes for j. I want to make few direct jumps for this j, right? So how I'm going to do this? So here for my dominant string, right, this condition should be valid. Number of zero square, it should be less than equal to ones, right? So here if you see how many ones I needed, right? So here how many ones I needed ones, you can say. So that is nothing but, so zeros square, that is nothing but 4, right, minus ones. So ones is 0 I have. So these are the number of ones I need, right? So after this, right, 0 0, if I have one, so definitely this is also not, this is not valid, right? Because we already see two zeros, right? And if I have two zeros, and then that simply means that zeros square is nothing but 4. So I need four ones, right? So that my zeros square become equal to ones for very first time, right? So I need at least four ones. So even if after this 0 we have 0, there is no benefit. Or even if I have 1 here after this, I have no benefit, right? This is not going to be valid. Even if I have 0 here, even if I have 1, right? Why I need to check this index starting from I. This j is invalid, this j is also going to be invalid, because until here we have already seen two zeros, right? So this is, I don't need to check this, right? I don't need to check this, right? Same way, I don't need to check this index. I don't need to check this index. I don't need to check this index. If my j makes jump here, right? If my j makes jump here from here to here, now see this. Now see this. Okay, so in this substring, number of zeros is 2 and number of ones is 4 now, right? So this is for very first time when my substring is going to be dominant one, right? Because my zero square is equal to number of ones, right? Clear? So this, I'm hopeful here, right? This may not be true, I'm just hopeful. I'm making a jump for j to here. I'm hopeful that I will see all the ones in this. There may be scenario when there may be zeros are there also, right? I'm here just hopeful that if only ones are there, then this is the minimum jump j can take, right? So here j is nothing but j is jumping, right? J is jumping, but it's hopeful, but it is hopeful, right? It is not guaranteed, it is not guaranteed that we will see the dominant substring only, right? But j, definitely j can skip all this, right? Because even if we have all three ones na, then also starting from here this substring will not make any sense, right? This is what I'm saying, right? So even if my j is here na, starting from here, this substring will not make any sense, right? Even if my j is here starting from this point, even if I have all ones, my j is not going to make any sense. But my j is going to make sense if it is here and starting from here. So it is going to make some sense, because if I have all four ones, then there is a possibility, right? Then there is a possibility of a dominant string, right? There is a possibility, because then maybe this is valid one, right? But if there is any zero somewhere here or here, anywhere, right? then then we need to check further, right? But here this is the minimum jump that j can take, right? So minimum jump, right? J is jumping minimum jump, you can say something like that. Okay, so I hope that this case is clear, right? So here I am just hopeful, right? So in this case, let me do one thing. Let me add this square box. Okay, so in this case, when number of zeros square is greater than once, so I am making j jump, right? How many times? How many times? So here, how many I can say? Needed ones is nothing but zeros square minus ones. So this is what I'm calculate, and my j is going to be new value of j, right? J is going to be j. Okay, initially my j is here, let's say. So j plus here needed ones, right? So here if you just give the index saying 0 index 1 index 2 index 3 index 4 index 5 index 6 index 7 index 8 index, right? So initially your j is at 3, right? J is equal to 3, right? And now in this window you calculate that needed ones is 4, so j is equal to j plus needed ones 3 plus 4, that is equal to 7. So j is going to make a jump to here, right? Then for this substring, first it is going to check that if this is valid or not, right? So in this case it is valid, right? Because my number of zero square is equal to ones, so that is nothing but my case 2. My case 2, when my zeros square is equal to number of ones, right? So if you just take the same example, right, so you can say 1 1 0 0 1 1 1 1, and here 0 1, what we are taking here 0 1 0, okay, something like that, right? So now here if this is the case I and j, right? So this case is very easy, right? So number of zeros in this case is 2, number of ones in this case is 4, and zeros square is equal to number of ones in this case, right? So 4 is equal to 4, right? So this is dominant string. So in this case just simply you have to just increment the value of count plus plus, right? So this is case 2, right? We have to just do count plus plus, that's it. If your zeros here square is equal to number of ones, that's it, right? And same way for case 1 you have to do this, right? If zero square is greater than ones, so needed ones you have to calculate, and then your j can directly make a jump to this position, right? Because this is the first scenario that you have to check first, right? In order to make sure that if this is valid or not, if this is dominant substring or not, right? Because if all ones then we are good, but if they are zeros then again you have to check further, right? So done, right? Now we are done with two cases. Now only one case is left, right? Case 3, last case, that is nothing but case 3, that is nothing but if your zeros square, right? So what we did for greater than and here equal to, and now less than, right? If zeros is less than number of ones, okay. So now in this case also we need to see if we can make any jump. So let's take the same example that we took for previously. So 1 1 0 0 1 1 1 1 0 1 0, right? Like this, something like this, okay. So now what you need to do here, let's say your I is here and j is here, okay. So in this case number of zeros if you see in this particular window is just 1, and number of ones in this window is nothing but 4. So, and zeros square uh, is less than number of ones, right? So 1 square is less than 4, 1 is less than 4, right? So this is our case 3, 0 square is less than, okay. So now in this case also we need to see how much jump we can take, right? So first thing is this is a valid window, right? This is also a valid window only. Dominant ones are here, right? So definitely you have to do this count plus plus here as well, right? So if I just draw one square box right here, so in this you have to do the count plus plus for very first time, right? So this is the first thing you need to do, okay. Now after that we need to check now that whether my j can move to this, right? So here we have to be very careful to, right? If there is a 0, right, then we may not need to add this, right? We may not need to add this j further, right? If there is a 0, right? So in this case if you see if I add this now, so this is valid only, right? Because number of zeros square should be less than equal to ones, right? This is for dominant, so this is valid only, right? But here again if let's suppose again 0 come, then you can't add this 0, right? Then this complete becomes not dominant one, not dominant ones, right? Because here zeros square 1 2 3 9 9 is greater than 4, right? So not valid, right? So we have to be careful about these j's, right? How we are moving this j further, right? So what we need to do here to move j further, so we have to very careful, okay. So first thing what you know that our number of zeros it should be less than equal to number of ones, right? For a valid dominant string, right? For a valid dominant ones substring, this is the case, right? Okay, you can also write it like this, na? Zeros, it should be less than square root of ones, right? Okay, so let's suppose if I add one more zero, right? If I add one more zero, right? So then zeros count will be incremented, and let's say still it is valid. Still it is less than equal to now square root of ones, right? Let's suppose I add one more zero, right? So zeros plus two more zeros, right? Still it is valid, right? Still this is valid, right? If this is the case, then it is valid. Same way, let's suppose if I have added k number of zeros, right? Zeros plus k number of zeros, right? Now in this case, for very first time, let's suppose this becomes equal to the this number of ones, right? Becomes equal to this case, right? This case, because here if you add one more zero right here, so now 0 square is 4, it is become equal to 4, right? Then after that, if there is any more zero na, then there is a one issue, right? Then there is some issue, there will be issue, right? So here I want to do safe jump only for j, safe jump always, right? Above also I was doing the safe jump only, right? I was hopeful, I was doing safe jump, and then I'm also making validating one more time, right? Again checking that particular complete substring, right? So here also I need to be hopeful, right? So here what I'm saying, so here I was hopeful, right? So if I make a j jump, then again I'm checking now that all these four should be ones only. If any one more zero is encountered, then again I'm checking, right? So same way here also, let's suppose this is for very first time we get after adding k zeros, right? This condition is becoming like this, right? So now here you can calculate the k value. K value is nothing but square root of ones minus zeros. So right, so this is nothing but the safe number of substrings that you can form. Safe number of substrings, safe number of substrings you can form, you can form, or you can say the jumps you can take, right? So here let's say you have uh one one one, okay, and let's say here you have 0 0 1 2 3 4 5 6 7 uh 7 we have it enough, so let's add, okay, 0 3 4 5 6, okay. Let's say your I is here, j is here, so number of ones is 1 2 3 4 5 6 7 8 9 9, okay. If I just give the indexing 0 1 2 3 4 5 6 7 8 9 10 11 12 13, okay. Number of ones is 9, and zeros is nothing but 0, right? So 0 square is less than ones, right? So, okay, so if this is valid, this is valid, right? This is one output, right? One output starting from this I, okay. So now here if I you just apply this formula k value, right? K is nothing but square root of ones minus zeros, that is nothing but 0 only for below example, right? So that is nothing but 3, so 3 more, k is nothing but 3, 3 is nothing but 3 more zeros you can add, right? So 3 more zeros, so if you add this 1 0, then you will get one more substring, right? This is also valid. If you add one more zero, then this is also valid. If you add one more zero, then this is also valid, right? But now from here you can't add this, right? You will get then not dominant one's answer, right? So this is a safe jump you can take, right? Safe jump that you can take, okay, until here. So first here count plus plus we need to do, and then after calculating the k value na, so you have to update the count as well, right? So in count, whatever the odd value, right? If how many safe jumps you can take, right? Safe jumps, right? That you have to add. So that is nothing but you can do count is equal to count plus this formula that we have calculated na? This k value, right? K number of more you can do, right? Okay, so k, why I'm writing k? So this is a fixed, right? Then three more na, 1 2 3. Okay, so three more, right? This is valid. Okay, but this is clear, right? Until now it is clear. Safe jump we can take. Okay, but here there is one more twist. There is one more twist. Let's say, let's say, let me just do one thing. Let me erase this. Let's say my output is like this, or my input is like this, right? So now there is one issue. There is one issue, right? So your k value is 3, right? So now you can't directly add k, because if you add k na, you are going to get reach here, which is nothing but the out of bound value, out of bound, right? So this case also, edge case also, you need to take care, right? So I will make sure, right, the jump that you are planning to take, right, if that jump is out of bound, then just break it, right? Then just break it and add this much value in the count instead of complete k, right? So here count is equal to plus is equal to k, or count is equal to plus equal to n minus 1 last index minus the value there old j was there, right? So this is what you need to do, and then just break it, right, your j loop, because j goes out of bound, you can't make any jump further, right? So this is what we need to do, right? So this is the plan. This is how we are going to solve this problem, right? So now in this case we are running off n square only in worst case, but if you see, we are making so many jumps for j, so many jumps for j, right? So definitely this, the new approach that I've told you, it is optimized one, right? And how much I have optimized it, let's discuss in the end. So now let's write the code, and in the end we will see the time complexity for this. Okay, how we reduce the time complexity for this problem, right? It will be of n square in worst case, but we are making some jumps, so let's say how much we reduced using that jumps, right? So first let's write the code, and then after that you have to calculate the prefix values, right? New int n, and here you have to write a prefix of 0 value as. So if the s dot character at 0 index, right, if it is equal to 1, so we are just counting the one frequency, right? So in that case you have to simply add 1 at this position, otherwise just add 0. Okay, and then here you have to just run one loop, int I is equal to 1, I is less than n, I plus plus, and here you have to update your prefix of I value as prefix of I minus 1 plus here s dot char. Okay, so here also I need to check na, s dot char at I, right? Here if this character at I, if it's equal to 1, in that case we have to add 1, right? Otherwise we have to add 0, right? So that's it. Okay, this is what we need to do, right? So this is done in of n time complexity, right? Now after that, create one variable count and set it to 0, and then we have to write start and or you can say left. Okay, int left is equal to 0, left is less than equal to n, less than n only, and here left plus plus. And now inside this you have to run like a right loop, right? Int right is equal to starting from left, and right is less than n, and here right plus plus. Okay, so we are running two nested loops of n square, but this right, we are going to make a lot of jumps for this right. Okay, so now let's write the code. Okay, So here what we need to do first, let's calculate the number of ones that we have. So I told you it's very easy now. Prefix of right, and here minus just check if your left is greater than 0, right? In that case you have to calculate prefix at left minus 1, right? Left minus 1, otherwise you have to take 0, right? So this is how you calculate the number of ones, and same way you calculate the number of zeros. That is nothing but the total length of your substring. So that is nothing but right minus left plus 1. Okay, and here in this you have to subtract ones, so you will get number of zeros as well. Now just do the square root of zeros, so that is nothing but you can write zeros into zeros. And now here case 1, right? If square of zeros is greater than ones, right, in that case just create one variable int need, how many ones you need. So square of zeros minus ones, and here you have to update your right. So okay, right is nothing but right plus need, right? And here just do -1 because we are also doing right plus plus here in the outer loop, right? That is why I'm doing need -1. Okay, because next time we need to check that particular string also, right? So here if you see case 1, so I'm making jump to here, so I'm just making it here because next time when my j is going to do plus plus, right, my right plus plus, so I need to check this also first, right? So that is why I'm just stopping it here only. Then in the next iteration when my j is here, right, I will check this, and then which case will be executed, this case will be executed then, right? So here that is nothing but square root of zeros is equal to ones. Then in that case just simply count plus plus, right? And in the else, that's nothing but case 3. So first I told you we have to do count plus plus for very first time, then we have to just update the need value as. So here I have derived one formula, right, int, and here you have to write math dot square root of ones, and here you have to write minus zeros, right? And then after that here how much jump you can do, right? So here int jump is nothing but right plus need. So this is a jump that you can take, but you didn't take any jump yet. So here you have to check first if jump is greater than equal to n, right? So if this is the case, then in that case you are going out of bound, right? So in that case in the count what you need to do, you have to add n minus 1 minus right, that's it. Okay, and just break it, no need to move further j, right, because you already go out of bound, right? But in other case, right, if jump is less than n, right, so then in the count what you need to do, you have to add this complete need value, right? And your jump, right, jump is going to be right is equal to the new jump value, right? This is the value you can take, and in the end here you have to simply count return count. Okay, that's it. So let's run the code and see if the code issue. Will try to fix that. So see, all the test cases has been accepted. Now let's see if we can submit it or not. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.